Right, hello everyone. So for this project, I decided to use Claude's help to create some Python scripts and create these machine learning models for our power plant data set. So what you'll see here is the first script. This is just a general linear regression. I've split this into 75% training, 15% validation, and 10% test data. Also forgot to mention, the first thing that I did with the data is to feature engineer to add values. So rather than just the initial letters, I actually spelled out, temperature, exhaust vacuum, etc. So that the model would have a bit clearer of a label to work with for what those numbers and what those values actually represented. So I wanted to go with linear regression to predict our target variable because the four features of feature variables lead into being able to predict that final variable, the power output. And so the performance of these models, I decided to go ahead and judge with root mean squared error, just that's the standard, and there was not very many outliers in this data. It seemed pretty consistent and not like there was not wild swings in the values. So I had built these scripts with Claude's help, so let's go ahead and run them now. So this is the first one, just the general linear regression. So you can see it's definitely working. Its root mean squared error is about 0.925 on the validation set and then 0.933 on the test set. So doing pretty well. It's nothing, not too bad. And it's definitely working. It's definitely better than guessing. So next I wanted to change a hyperparameter. So I wanted to run a ridge regression and then mess with the alpha variable to either lessen the penalty or increase the penalty on deviations and like outlying values. So that was V2, and that is visible here in the script. So this is going to be a ridge model, and we want to run a range of alpha values from 0.001 up to 1,000 and see which one is going to perform best. So let's take a look at that one. Let's run that script. Right, and so this one doesn't really tell us anything because, again, the values in the initial data set were pretty well aligned and in expected parameters. There were not any crazy outliers. So changing the alpha parameter didn't really do anything here. So next up, Claude had suggested that I try an entirely different algorithm. So here we went with a decision tree regression. So you can see here we've changed the type of algorithm that we're going to use. And then again, we're going to see what depth that tree works best at. So we're going to try a bunch of different ones and see which one gives us the best value. So let's run that one. All right, and so it found that the best depth is 7. That gives us a root mean squared error of 0.945, which is a little bit better than our linear regression. So it seems like this is the way to go. It gives us a little bit of an advantage here. And as you can see at the very bottom, it compares it's a slight better, like slightly better values than our initial linear regression model. So that is how I had built these models and tested and validated them, and couldn't have done it without the help of Claude.